Hello everybody, this paper is about Tesla code. The title of this paper is Different Numeral Systems Correspond to Different Universes, revealing the secret behind Nikola Tesla code of 369. Here is the abstract. The statement of Nikola Tesla that if you knew the magnificence of 3, 6, and 9, you would have a key to the universe, implies that there must be something special about these three numbers, 3, 6, 9. And it is demonstrated that the underlying reason for this specialty is the employment of a decimal system. In decimal system, there are 10 bases, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And these 10 numbers serve as elementary particles to establish the numerous world. If a different numeral system is employed, these three numbers, 3, 6, 9, may lose their magnificence or even may not exist. And it is proved that in base n numeral system, the digital root of the sum of the interior angles of a polygon is equal to n minus 1. And here we introduce a concept called digital root. Here we have three examples. Example 1, the digital root of 32 is 5, because 3 plus 2 equals 5. And example 2, the digital root of 128 is 2, because the first step, 1 plus 2 plus 8 equals 11. And the second step is that 1 plus 1 equals 2. Example 3, the digital root of 256 is 4, because the first step is that 2 plus 5 plus 6 equals 13, and the second step is 1 plus 3 equals 4. So, in sum, the digital root of a non-negative integer is the single-digit value obtained through a process in which iterative summing digits is conducted, and each iteration is based on the result from the previous iteration. Here we see a sequence 1, 2, 4, 8, 16, 32, 64, 128, 256, 512, and so on. In which each item is twice of the previous item. Its corresponding digital root sequence is 1, 2, 4, 8, 7, 5, 1, 2, 4, 8, 7, 5. This repeated pattern 1, 2, 4, 8, 7, 5 appears. And we will explain that this repeated pattern is caused by the employment of a decimal system. If a different numeral system is employed, there will be a different repeated pattern of a digital root. This slide talks about in base 9 numeral system, what is the pattern of the digital root sequence of the number sequence 1, 2, 4, 8, 16, 32, 64, 1, 2, 8, 2, 4, 6, and so on. In base 9 numeral system, there is no 9. The basis to construct a base 9 numeral system are 0, 1, 2, 3, 4, 5, 6, 7, 8. And 1 plus 8 equals 1, 0 in base 9 numerous system. And we write it as 1 with subscript 9 plus 8 with subscript 9 equals 1, 0 with subscript 9. And recall that in decimal system, it is a base 10 system. 1 plus 8 equals 9. We write it as 1 with subscript 10 plus 8 with subscript 10 equals 9 with subscript 10. As to number 16, if it is from base 9 numeral system, it is written as 17 with subscript 9. And if it is from decimal system, it is written as 16 with subscript 10. That is for the same number 16. For this same number 16, it is written as 17 in base 9 numeral system. The digital root of 16, it is written as 17 with subscript 9, is 8 in base 9 numeral system. So for number 16, its digital root is 8 in base 9 numeral system. And for number 32, we can know that its digital root is 8 in base 9 numeral system. So in base 9 numeral system, the digital root sequence is 1, 2, 4, 8, 8, 8, and so on. For the number sequence 1, 2, 4, 8, 16, 32, 64, and so on. This repeated pattern 1, 2, 4, 8, 8, 8 is different from the pattern we obtained in decimal system. This shows that the repeated patterns of digital roots in different numeral systems are different for the same sequence 1, 2, 4, 8, 16, 32, 64, and so on. In base 10 system, the repeated pattern is 1, 2, 4, 8, 7, 5, 1, 2, 4, 8, 7, 5, and so on. In base 9 system, the repeated pattern is 1, 2, 4, 8, 8, 8, and so on. In base 8 system, the repeated pattern is 1, 2, 4, 1, 2, 4, 1, 2, 4, and so on. In base 13 system, the repeated pattern is 1, 2, 4, 8, 4, 8, 4, 8, and so on. In base 12 numeral system, the repeated pattern is 1, 2, 4, 8, 5, 8. 8 here is 10. 9, 7, 3, 6, 1, 2. The next number is here is 4. And the next is 8. In base 11 system, the repeated pattern is 1, 2, 4, 8, 6, 2, 4, 8, 6, 2, 4, 8, and so on. This slide talks about the digital root of the sum of the interior angles of an n-side polygon in different numeral systems. For a triangle, here, the number of sides is 3, and the sum of the interior angle is 180, and the digital root is 9, because 1 plus 8 plus 0 equals 9. For a quadrilateral, the number of sides is 4. The sum of the interior angle is 360. the digital root is 9, because 3 plus 6 plus 0 equals 9. For a pentagon, the number of sides is 5, and the sum of interior angle is 540, and the digital root is 9, because 5 plus 4 plus 0 equals 9. And for a hexagon, the number of sides is 6. The sum of interior angles is 720, and the digital root is 9, because 7 plus 2 plus 0 is 9. The reason why here is always 9 is that we employ decimal system to measure these numbers. In decimal system, number 9 represents the end of the universe described by this numeral system. In base 9 numeral system, number 8 represents the end of the universe. In base 8 numeral system, number 7 represents the end of the universe. In base 7 numeral system, number 6 represents the end of the universe. Generally speaking, in base n numeral system, number n minus 1 represents the end of the universe. In decimal system, we say two straight lines are perpendicular to each other if the two meet each other at 90 degrees. Here it shows a circle in a universe described by decimal system. And in base 9 numeral system, we say two straight lines are perpendicular to each other if the two meet each other at 80 degrees. Here is a circle in a universe described by base 9 numeral system. The digital root of the sum of the interior angles of an n-sided polygon in base 9 numeral system is always 8. In base 9 numeral system, the sum of the interior angles of an n-sided polygon can be calculated according to the formula. Its side number minus 2 and then multiplied by 160. For a triangle, the sum of the interior angles is 160, and 160 in decimal system is equal to 187 in base 9 system, and the digital root is 8, because for this number 187, 1 plus 8 plus 7 equals 17 in base 9 system, and 1 plus 7 equals 8 in base 9 system. For a quadrilateral, the sum of the interior angles is 320 degrees. And 320 in decimal system is equal to 385 in base 9 system. And the digital root is 8, because we see here that 3 plus 8 plus 5 equals 17 in base 9 system, and 1 plus 7 equals 8 in base 9 system. For a pentagon, the sum of interior angle is 480 degrees, and 480 in decimal system is equal to 583 in base 9 system, and the digital root is 8, because we see here that 5 plus 8 plus 3 equals 17 in base 9 system, and 1 plus 7 equals 8 in base 9 system, and so on. So the digital root is always 8 in base 9 numerous system. Here it is a table that shows the digital root of the sum of interior angles of a polygon in different numerous systems. We can see here that in decimal system, the digital root is always 9. In base 9 system, the digital root is always 8. In base 8 system, the digital root is always 7. In base 13 system, the digital root is always C. C here represents 12. In base 12 system, the digital root is always B. B here represents 11. In base 11 system, the digital root is always A. A here represents 10. When we measure this word by numbers, we need to keep in mind what numerous system we use. Normally, we use decimal system, but there are many other numerous systems. Here, it shows the bases in different numerous systems. In base 11 numerous system, the bases are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 8. A here represents 10. And in base 12 numerous system, the bases are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B. B here represents 11. And in base 13 numerous system, the bases are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C. C here represents 12. Thank you.